So welcome everyone to the workshop today, which is on facilitating local multi-vector energy systems with the ELN Toolbox. So we are here on presenting from the Horizon 2020 project ELN, and I myself am Sanket Puranik, Senior Researcher with Smart Innovation Norway. We are the scientific coordinator of the ELN project, and we are a non-profit organization located, as the name suggests, in Norway. I have been working with design optimization of energy system and developing business models for energy-related innovations. I have been also leading work package on business model development and exploitation for the ELAN project, and have been parallelly working on other research and innovation projects funded under Horizon 2020 schemes. So that was my brief introduction. The goal of the today's workshop is threefold. First, to showcase the multi-vector energy planning and operation tools which are developed in the project. Then to get feedback from broader stakeholders on what they think about the tools, what are the relevant features with their business context, and together with them to identify what are the future exploitation pathways on how the tools, the technical tools which are developed in the project can be used for their projects or in their businesses to improve their current energy system performance. So together with them, we will discuss what are the possible pathways which exist, and then we see how we go forward. In order to do that, the agenda for today looks like this. First, we will start with welcome and introduction to the project. Then we will move on to describing different tools which are developed in the project. First relates to the long-term investment planning on multi-vector energy systems. Then we have short-term operations planning using the multi-vector operational optimization tool. Then we take a short break, and then we move on to how these tools were actually implemented in the pilot sites of ELN project through integration of local energy system infrastructure. And then at the end, we will have a co-creation session where we will discuss together with you and get your feedback first on what do you think about the tool, what are the relevant features, and what are the features which could be added in order to make it just suitable for your use in the future. And also, as I mentioned, together with you to brainstorm on possible future exploitation pathways. So I welcome you again, and let's start with the introduction to the project itself. So the ELN project is funded under European Union's Horizon 2020 Innovation Program. We are 12 European partners who are participating, and the whole consortium is led by University of Girona with scientific coordination belonging to Smart Innovation Norway, the company which I represent. Along with this, we also have two Indian collaboration partners, which are basically simulated pilot sites in India, where we investigate applicability and replicability of the tools which we are developing in the project in the context of Indian landscape. So in the project, we are tackling the global challenges regarding climate change, and how we do that is by decarbonizing energy systems at the local level, with having a key focus on energy communities, especially those which are isolated. And we intend to meet the global challenge by providing local solutions so that the energy system at the local level are clean and green. Specifically, we look into the challenges falling into three categories. First is the technology challenges, where we look into how different energy vectors and sectors which are currently decoupled can be integrated and planned in more efficient way in a joint fashion. Then we also look into how the seasonal imbalance can be met by different type of storages, the technological solution available in the form of seasonal storage. At the societal level, we look into understand what are the roles the communities play, what are the different roles played by the members of the community, how the dynamics in the community happens, and how it can be leveraged to form a well-performing energy community. And also we look into the gender roles within the community and how this can be leveraged in order to support the formation of a sustainable energy community. Then into the business related challenges, as goes with any other technology, if it has to be successful, it has to be economically viable. So we look into what are the relevant business models which can be developed for local energy system, focusing on local energy communities, and how this business model can support functioning at the community level. We develop new business model, as well as we look into new business models, we develop into updating the existing business model. Going forward, in order to meet these challenges, the ELN develops a specific toolbox for multi-energy islands. And this toolbox offers different methodologies, different tools in order to support energy islands and isolated communities which are built on the foundation of multi-energy systems. Specifically, the goal of the project is to develop multi-vector energy optimization algorithms, which can digitally interconnect different energy resources, develop and integrate the needed technological tools with the existing energy system at place, increase the use, further develop and validate the new business model, which are also innovative, develop economically viable system at the pilot site, which are self-sustaining and also have lifetime beyond the project. To understand how the dynamics of existing communities can be used and explored further. We also investigate and enforce the role of citizens and communities as an active player in implementing new technology. Finally, we aim at implementing the modular toolbox, which provides tools in technical, community, and business levels. So here is a high-level overview of the ELN Toolbox, which we have talked about, that this is what we offer as a solution to the global challenges we are tackling. And here you can see the three layers of the ELN Toolbox: the community building tools, the business development tools, and the technological tools. In the bottom, you can see that there are different pilot sites which will be connected to the ELN Toolbox in order to support them with better energy decisions. The goal of today's workshop, however, is only on the technical tools. So we will not be talking about the community tools or the business development tools, but the focus rather is on the technical toolbox. This is a context overview of the technical toolbox. As you can see here on the bottom, this energy management system, which is present at the local sites. Different energy resources can have different energy management system, or there could be a common energy management system for distributed energy resources. So we take the existing energy management system, we couple it with the new ELN technical tools using Enterprise Service Bus. So this is the integration tools which connects the existing management system to the additional tools which are developed in the project. And just to remind you all that this is a digital integration. We are not talking about physical integration. We are digitally connecting existing energy resources at the pilot sites using Enterprise Service Bus to provide them additional functionalities and features which the novel tools, which we will discuss in more detail going forward, offers. So broadly, the tools can be divided into three parts. One is the long-term planning, then the short-term operation planning tool, and then the integration tool. I will not go into the details as we have experts who will explain these tools going forward. Here in the project, we have 9 use cases or technical use cases which will be implemented through the 3 pilot sites which are in Europe. One is a university. I will discuss more about it. One is located in Romania, second in Spain, and third in Norway. Additionally, we have 2 pilot sites in India which are simulated. So what are these use cases? The first is to provide commercial functionality to multi-vector local energy system, and how different services which can be developed by integrating different energy vectors and how those can be leveraged from commercial standpoint. This is investigated here. And this will be implemented at the Spanish pilot site. Shifting building loads and through demand side management, looking into different buildings and how the loads can be managed. Shifting harbor loads using demand side management. This is a key focus on the Norwegian pallet, which is harbor. Optimal scheduling of thermal and electrical storage. That is focus of the Romanian pilot and Norwegian pilot, where these two different storages are located and will be optimally planned. Then we have optimal scheduling of electrical storage and hydrogen storage. That is the focus of the Spanish palette, where the hydrogen electrolyzer is located. Then we look into storing excess generation in the thermal network. That aspect will be looked into detail in the Romanian pilot, where the pilot has access to the thermal network. Optimal management of electric vehicles, fuel cell vehicles in local energy systems. This is focus of all the three pilots except the Romanian. Then multi-vector optimization of asset sizing, how to size the assets in the longer run, considering the multi-vector as optimization, and how to size the local energy system, considering the electrical network. That is the use case 9. So here you can see use case 2 to 7 are focused on operation planning, and 8 to 9 are focused on long-term investment planning, considering both only electricity network as well as the multi-vector aspect. So I talked about the pilots. What are these pilots? We will just discuss what are the key characteristics of the different pilots of the project. So the physical pilots, where the tools will be implemented, are located in the 3 countries in Europe: Norway, Spain, and Romania. In Norway, it's a port, where the port has its traditional loads in form of moving the containers. They have different buildings which consume energy for different needs, as well as they have upcoming demand for electrifying the ships. So this is very peculiar when it comes to the different systems which needs to be, or different energy systems which needs to be optimized at the port. Then we have a university campus in Romania, where the campus has its own electricity generation through PV. They have solar thermal generation. They have their own district heating network. They have multiple buildings which have the different demands and which can be managed in a way to integrate more renewable energy. But right now, they are optimized in an isolated fashion, and through the project and through the ELN tools, they want to integrate the optimization of different building loads as well as the different vectors, that is thermal and electrical, which is present at the university campus. Then we have the Spanish palette, which is the Valka Technological Park. It's as name suggests, a business park where different companies are located, and they have their own photovoltaic electricity generation. They have an hydrogen electrolyzer. They have a electrical battery storage as well. So there are different assets which are connected to different vectors, which needs to be integrated and optimally planned. So this is an integrated overview. On the right hand side, you can see of all the 3 palette sites combined, where we have the gas grid, electricity grid, the thermal grid, which are interconnected in reality, but they are operated in an isolated fashion, which leads to a non-optimal performance. So using the technical tools or multi-vector optimization tools, which will be discussed further, the aim is to better plan the local energy systems. And then, as I mentioned, there are 2 simulated pilots in India. One is a residential community, which is supplied by a distribution system operator in New Delhi. So there they have rooftop PV, there is a few batteries available, and there is a plan or target by the Delhi government to increase the solar generation at the local level, as well as to support EV in the market. So this is going to affect the operations of DSOs, and DSO needs to find how they can optimally manage different sectors together now, not just the electricity which they have been doing in a traditional business. Then we have an energy community which is located at South India, which is Orwell. It's a unique energy community which wants to be self-reliant on its own energy needs. For that, they have already done some investments into distributed energy generation and are looking further how they can decarbonize themselves, and then they can take control over their own energy needs. And for that, the ELN tools are perfect fit for their requirements, and we will, using simulation, investigate how they can further achieve their goals. The agenda for today looks somewhat like this. As I already mentioned, we covered the introduction right now, and now we will go towards our first presenter from the technical tool, that is Martha from Rainer Lemon Institute and Isidoras from Intracom Telecom.
Thank you. I will share my screen now.
Yes, I will stop sharing.
Yes. It's not popping up for some reason. Okay, maybe it works now.
Yes.
Yeah, somehow it's not popping up. Maybe you have to share the screen.
All right.
I can't for some reason. Yeah, thank you.
No problem. I can take control from here. Yes.
Okay.
Let me put it in the right setting. All right.
All right. Thank you very much.
The floor is yours. Just an update. I will just remind you when your time is about to be finished. Yeah.
Okay. Thank you. Okay, then I will start with a short introduction of myself. I'm a researcher at the Rainer Lemon Institute in Berlin. We are doing mostly energy system modeling revolving around renewable energies on different scales, so local, regional, country, and European scales in different teams. And I'm a researcher in the off-grid team, which is mostly focusing on electrification and also decentralized energy systems. And ELAN is looking at local energy systems. So this is a project that fits us well, of course. Yeah, and I've been developing the multi-vector simulator, one of the key tools in the ELN Toolbox, and will be presenting this now. You can go to the next slide, please. Thank you. So our tools, the tools that we are starting with, are in the right-hand corner. It's a multi-vector simulator and energy planning application. And both of those tools are preliminary to you really implementing a sector-coupled energy system, because first, before you do anything, you should plan your system. You should know which assets you want to have in your future energy system. And that's where the multi-vector simulator and the energy planning application can help you first and foremost. Can you go to the next slide? Thank you. The multi-vector simulator and the energy planning application are both investment planning tools, but they are a little bit different. So the multi-vector simulator is a computer core operation that does optimization, and I think it's better suited for energy system modelers and researchers. And then around that, we built the energy planning application, which has a graphical user interface, and which colleague Isidoras will show us later as well. Both tools can then perform a long-term investment planning optimization of your system and will therefore define the optimal capacities that you should install at your location to minimize your costs. The same goes for the dispatch. It will optimize the dispatch of each of the assets, and then in the end, it will do a performance evaluation of your energy system. So what's the costs, what's the renewable factor, and so on. And we will learn more on the next slide, where I've noted down the different features of the tools. The black features are features of both the MVS and the EPA, and the red features are the ones that just the MVS has, so the multi-vector simulator, because the multi-vector simulator is always developed first, and then we follow with the EPA, so MVS is always a bit ahead. The MVS and EPA allow to really define your energy system as it is at your location. So you can define a different diverse set of assets. You can define multiple buses and how those assets interconnect. You can include the sectors that you want to consider: electricity, heat, hydrogen, gas, just what you like. In the MVS, you can then put some constraints on your energy system optimization, so minimal renewable share and the like. You can define parameters like the energy price and efficiencies as time series, can consider revenue through feed-in to the grid. You can also consider if your energy provider requires some peak demand pricing from you and you want to reduce that part of your electricity bill. You can use multiple demand profiles, also with different energy carriers. And when you use MVS, you also can export the results to PDF. Or when you use EPA or MVS, you can also report this to Excel sheets and post-process later and share it with your colleagues. Now we can go to the next slide. Yes, so here we can see how the general structure of the flow is for the investment planning tools. So first, for all energy system models, there's just a big set of data that you need to provide for the energy system model to work. And that includes some general data about your project lifetime, some economic data like the weighted average cost of capital, your demand profiles, your resource profiles of renewables, some technical data, and cost data from all the assets that you are considering to invest in. The MVS then takes this inputs either through the energy modeler inputs or from the EPA and creates an energy system model using UMOF, which I will explain later. It can then solve this linear problem and find your optimal capacities and optimal dispatch of the assets. With that, it will then calculate the key performance indicators, namely levelized cost of electricity, heat, hydrogen, the net present value of your system, upfront investment costs, operation and maintenance costs, renewable factor within the system or overall, degree of autonomy, asset dispatch, and CO2 emissions. There's also a number of more KPIs, but I cannot list them all now. Can you go to the next slide? Yeah, so as I explained, the core behind the MVS is UMOF. UMOF is Open Energy Modeling Framework, and it's an open source package, or actually a group of packages that's available on GitHub. It is developed with a couple of institutions and a lot of people that don't necessarily are in specific institutions, and therefore it's collaborative. It is modular because it has different packages suited for different energy system modeling needs. So, for example, demand time series or UMOF solve, which we are using to model the energy system. The reasoning why we're using UMOF solve is that we believe at the LI that research should be replicable, accessible, and reproducible, and we think that open source energy system modeling is better suited for this than black box energy systems. Can you go to the next slide? Thank you. Because we use UMOF at its core, we have a couple of core components that we can use and that can be translated in all of the different energy carriers that we are looking at, all the different energy vectors. So we have sinks, which are basically demands. We have sources, which are renewable generation sources or other kind of sources. We have transformers, which are energy conversion assets. So it converts, for example, electricity to heat in a heat pump, but it could also be an electrical inverter. We have energy storages, so battery storage, but also thermal storages. And then in between, we always have buses, which then interconnect those four basic types of energy assets. So before you do any modeling, you would always have to translate your energy system in those generic types, and then you can use MVS and the EPA. Next slide, please. Yep. When you've built this energy system and provided all the technical data and all the cost data, OMOF, so the Open Energy Modeling Framework, will create a linear optimization, a linear equation system, which has to be solved later on. And the optimization goal is always to minimize your annual energy supply costs. So you can see the function that's being optimized, or actually minimized in this case, and we are minimizing the investment costs, so the annuity of the investment costs, the annuity of the operation and maintenance costs, and then also the dispatch. And therefore, at the same time, we get the optimal dispatch and the optimal capacities. It happens in one step. Can you go to the next slide, please? Thank you. Because we are using OMOF in this linear representation, there are a couple of limitations to our energy system. We cannot use any non-linear representations. So basically, our generators currently don't have efficiency curves, and there's no charging efficiency that's dependent on the state of charge. It's also that we are not able to use price changes that happen in the future. So if you want to display a learning curve, the effect of a learning curve, you would have to account that in the input factors. It also uses perfect foresight, and there's no electrotechnical power flow analysis included. All of this means that while the MVS is very adaptive and can really help you to figure out in which assets you should look more into, you should not understand the MVS as something that plans your electricity grid, because it's more of a pre-visibility tool that helps you to identify the business cases that are best for your location. Can you go to the next slide, please? Thank you. If you want to use MVS as a standalone solution, so if you're a researcher, if you're an energy system modeler, if you're a little bit keen to use with some programming or to use a terminal, then you can use it as a standalone solution. You would need Python, you would need to install a solver, something like PyCharm, and then it's pretty fast forward because we have provided the MVS as a package on PyPy. You can follow the installation instructions, and then you can enter your data in CSV files as it's shown on the right side. So there's a number of CSV files that you would have then to fill. You can run the simulation, and then you will get the results. It also might be interesting if you're an energy system modeler and a programmer, and if you want to change any functions. Can you go to the next slide? Here you can see where the MVS is available. It's available on GitHub, and notably it has a GPL v2 license, so it's free to use and approve and fork. So really, if you're interested to use it, you can just take a look and install it on your computer and try around, and you're free to do whatever you want. It's on PyPy, as I explained, and there's also vast documentation and a graphical user face if you're not that keen on looking into the programming part of this. On the next slide, we can see how the documentation looks. So it's online and therefore always up to date. And you can also inquire there what the input parameters are and figure out some more information about the key performance indicators or assumptions that went into the model. So I encourage you to look into this if you consider the MVS. Then on the next slide, I have an example of the MVS just to highlight what we can do with the MVS. As Sanke had already explained, we have a pilot in India, in Delhi, and this is BYPL. And BYPL has a community called Saini Enclave, and they're expecting that more and more households will install solar on their rooftops. And they want to know which effect does this have on our operation, how can we react, and so on. So our task is now to define what the scale of consumerism might be in Saini Enclave, and then how BioPL can react to it, if it receives losses, if it should maybe install local batteries. And on the next slide, we define 4 scenarios to assess this. The first would be that we are looking at the different feeders and batteries and PV panels that BioPL already has installed. And we identify how currently their costs are distributed and how much revenue they make. In a second phase, we would optimize kind of the global optimum. So we would determine if from BioPL side, it would be better if PV was rather installed at their sites or at the residential households. In a third scenario, we're looking at presumerism, and for that, we also just look at the households themselves and optimize how much PV and batteries households should install to minimize their annual electricity costs. And in the fourth scenario, we are checking how this ideal and cheapest PV capacity for presumers would impact the energy system of BioPL, how much revenue loss I would have, or if there's also chances in installing batteries, how they have to adapt their energy system in general. I don't have with me any preliminary results, but if you're keen to know more, you can also follow up with me. And I think with that, I would hand over to Isidoris to show you how you can use the MVS with a graphical user interface.
Thank you, Martha. So hello from my side. Sanket, I suggest we keep the same presenter, and I will just ask you to change the slide. So hello from my side again. This is Sidoros. I'm a senior R&D engineer within Tracom Telecom from quite a few years now. I'm engaged in projects in the research and innovation context under the umbrella of smart grids, mostly engaged in technical analysis, design and implementation of software solutions in the domain. My background is in electrical and computer engineering, and in ELN, I've been leading the work package on requirements analysis and design. And ICOM as a solution provider has also provided a series of IT solutions tackling different aspects in the project. So the first one is EPA. So Sanket, if you can go please to the next slide, which just to describe the problem is fairly simple. So we wanted to provide the features of MVS, the ability to do investment planning in a local energy system without having the barrier of programming skills. So you're an energy expert, you want to do this planning, and you don't know, or you're not very confident in using the console and stuff. So what we've built is a solution, a web application, which hopefully has an intuitive user interface. The solution can support multiple case studies representing different solutions of interest, different setup yet you are interested in modeling in the local energy system. There's a drag and drop tool for modeling the grid infrastructure, which we'll see in a demo later on. And it can support multiple users. And finally, we followed the paradigm of RLI, which offers the solution as open source, to the community to be assessed, to be evolve. So we have this also as an open source solution under MIT license. The code is not yet available, but it will soon be as we mature the solution in the project. And just one click, that's a sample of the model of how we present the grid model of the system with the different assets, what was called as buses, connecting the different assets, even for multi-vector, for connecting assets in different vectors, for instance, heat and electricity, right? So if we can move to the next slide. There's a demo that we'll present later on, but I want to go through the process of how you essentially use the tool, just to have this in mind when you're seeing the video. So first of all, you're creating a project. The project provides all the necessary information for having a context of the analysis, the name, the location, currency, and under the project we have scenarios. Scenarios are specific case studies that you can model in the system. Just one more click, Sanket, please. Thanks. And then you can specify what's the simulation time step, the evaluation period, and relevant project costs. Then there's what could be considered as an offline step. So all these files that were mentioned by Martha previously on time series data or technical data on the existing or asset of interest, economical data, all this, you need to gather this information to import them in the tool to create the simulation. This is one of the, I guess, the most challenging steps in the process. And then you create your visualization of the system, the energy system modeling. In the first phase, you can model the assets and use the data you have collected to provide the values, the technical or economical values, select which assets are to be optimized. And then you can fine-tune the model, actually finalize it by providing all the buses, how connect them, the assets in a meaningful way, validate it, save it, and finally, in the final step, you can request for a simulation. One more click, please. And you're waiting for the response. And finally, you check the outputs and you can assess the different results for your case studies. Now, there's a video that in the next slide. So Sanket, can you share the video, or should I? If you can stop sharing, I can share it.
Yes, I've stopped sharing.
Yes, thank you. I will just open this and share this. So this homepage of the application, there's also an introduction to the ELN project. This is hosted actually to RLI service, publicly available. Users can register in the application, and upon login, you can see your projects. There's also a map to provide the location of the different projects, and you can create new project using form, providing short name, description, the country, and all this information that we think are of interest to defining the, let's say, the high-level structure. And you can manage the projects here, and you can even share project with other collaborators by providing their email. Then in each project, you can define scenarios. In each scenario, you specify, as we said, valuation period, some cost indexes, when the simulation, let's say, the candidate to start the simulation. And through this step, you can provide different scenarios. You can create different scenarios, but as we'll see next, you can also copy scenarios and reuse the existing, let's say, information, not to do the whole thing again, just to modify one parameter. You can also keep track of the project by adding comments on specific items. And as mentioned, and in previous manner, you can edit, you can manage the scenarios here as in the project page. And here we see an example of creating a copy. So you can, of course, change the name and tweak some of the parameters if you don't want to rebuild the whole thing. And this doesn't seem so complex now, but if we drill now to the system, the grid model of the system, if you copy this, it's fairly simpler to model everything and skip avoiding the grid modeling. Anyway, so this is a drag and drop tool where you provide the assets and the links among the assets in the grid. It's drag and drop. You just put it there. You open the form and you provide all the information. You need to provide the information prior to saving. There is also validation of the fields and tooltips to help you go through this, which is again a challenging process in many occasions. And you can provide time series, this CSV files or the text files that you need to do the simulation. And then upon saving, you can request for the simulation. Now, this step usually takes longer, but yeah, we have shortened for the purpose of the video. And you get the results of the simulation. You can visualize these results in graphs, such as the pie charts we see on the top, where you have different performance indexes of the simulation. You can download this in XLSX format, and then you have specific indexes in this tabular form, where you can again see cost indexes, environmental indexes. You can search within these indexes. You can again download this, and finally there is a page where you there's a tool where you can see graphs of the time series that were used in the input or was the output of the simulation performed by MVS. Again, you can download it. There's a feedback page where you can provide your comments, your request for support, and all this stuff. And that's it for the video. And now I guess I can conclude. I can stop sharing. Do you want to reshare, Sanket, the next slide?
Yeah, there's only one slide left, so all right, let me do that.
Okay, lessons learned. So from this experience with Among Airline and ICOM, we understand that it's very beneficial to start integrating very early. It's important to specify the tests and also benchmarks. Okay, that mostly applies to MVS simulations. It's important to give feedback to the open source community, right? And essentially, it's important to onboard the users in the design process and validating the prototypes that you're building. And this is it from my end. Floor is for Sanket. You want to go to the Q&A section, or?
Yeah, now we have some time left for Q&A for the audience. If they have any questions to ask regarding multi-vector simulator and energy planning application, please feel free to ask. I see no questions in the chat as well. Okay. So I will ask us a question to Isidoros regarding energy planning application. What are the next steps with respect to the EPA? What needs, are you planning to add some more additional features or more functionality?
Mm-hmm. So we already have several people involved in the process, different workshops with more close, let's say, environment with either the pilots or collaborators with the pilots, and get some early feedback on extra features, which we want to assess and see how we can evolve this. Hopefully, we can do this in another context, another project. In any case, this would be, as mentioned, an open source, released as an open source tool. It will be committed in a public repo, and we will also leave the community to be involved if they can to progress this. In any case, one of the intentions of the workshop is to get some feedback from a broader group and assess what could be the next steps, extra features or collaborations of this tool.
Okay, thank you. For a question for Martha, you mentioned this, the modeling tool is quite modular and it can be used to assess different energy technologies. How extensive is the energy technology library in UMOF or for the MVS tool right now?
So in the MVS tool, you have to break it down to the 4 typical assets that I explained. That's actually applicable to the EPA. If you are using the MVS, there's also already an advanced thermal storage included, because of Solve actually includes more assets, so more specific assets like CHPs and so on, so very specific ones. And in future modeling, it would be very interesting to also integrate those in the MVS. But for the ELN project, it was sufficient to look at the 4 core ones to solve all our problems.
I see. Any so far with your experience with the ELN piloting, is there any interesting outcome you would like to share today?
So together with the energy planning application, we have had a couple of workshops, 2 more theoretical ones where we discussed the user interface of the EPA and where we got some feedback, and where Isidoris and his colleagues also improved the EPA further. And now this summer we had 2 workshops, or actually 4 workshops with the Indian pilot sites, where it was really interesting to jointly with them develop energy system models, so the grid view that Isidoris showed you. And I think that that would be something really interesting to go forward with also the other pilots. For the second, like for BioIPL pilot, the example that I showed you before, I can also say that we are going for a conference publication about the role of prosumers at BioIPL, because I think there will be quite some interesting findings, which it's too early to share.
All right. So if there are any questions from the participants, they can just write in the chat or use the Q&A functionality. We will answer it on the go. Now it's time to move on to our next speaker, that is Sergio from University of Girona, and he will be talking about multi-vector operational planning, that is short-term operational planning. Sergio, the floor is yours.
Okay, thank you, Sanket. I have shared my screen, and I think that you will be able to...
Yes, you have to go to presentation mode and swap the presentation.
This one?
Yeah.
No,
that was right one and the first option.
Okay. Thanks, Sanket.
Yes.
Okay, so I'm just going to explain a little bit about this second set of tools that form part of the LAN Toolbox that are related with the multi-vector operational optimization. Before I start, there's a quick introduction of myself. My name is Sergey Wright. I'm a lecturer and researcher at the Institute of Informatics and Applications in the University of Girona in Spain. Mainly I'm working from a lecturer point of view in the area of electrical power systems, modeling operation, and power quality. And in the research areas, I'm focusing power quality and energy efficient and in power systems, smart grids and smart buildings. My background, I'm an industrial engineer, specialized in electrical engineering and PhD in industrial engineering. So just to introduce this set of tools, the LAN Toolbox, besides the tools that Marta and Isidoros have just explained, includes a set of technical tools that enable to optimize the operation of the local energy systems when it is working. Once the assets, say generation assets in the local energy systems or the storage assets in the local energy systems, and the assets that can be controllable are in place. So these tools are in charge to operate them in order to, first of all, the main objective, calculate or to plan when and how to consume and store energy to optimize the use of the local distributed energy resources, that is the generation resources and the storage. To perform this, we will need to forecast both consumption and demand energy. So this optimal scheduler tool leverage the power forecasting. This is the second tool that we will present for short-term forecasting in order to perform this short-term operational planning. Harness the data that is gathered in the field, in the local energy systems by the local monitoring systems that are in place in the field, making an intermediate step, meaning that improving its quality. I'll just explain later on what this means, and integrating these tools with the existing or newly deployed energy management solutions that are in the field, in the local energy systems, via the Enterprise Service Bus. That's another tool that is developed by ICOM and will be explained by Sidros later on. Considering, and this is one of the main features of these tools, a multi-vector energy scenario, considering electricity, thermal, hydrogen, electromobility energy vectors in the definition of the local energy systems. Just to focus these tools in the ELN Toolbox, here in the slide, just highlighted in red, is where I've located these tools. They are related with the short-term operation. I can say that the main tool is the optimized scheduler, and the other two tools, the data processing application and the energy forecaster, and tools that are needed to perform these calculations, to obtain these scheduling plans for in a short-term horizon. Just to visualize results obtained from this optimization or key performance indicators that can inform the user how these tools, how well these tools are performed. There is a fourth tool in the LAN Toolbox that is an interface, an interface that is called Data Visualization Application, and in this slot we will dedicate some time to talk also about this fourth tool that is for the visualization of the results in terms of the performance of the sorry of the operational tools, how well they are performing, how well they are the results that are providing to the local energy system. So just to enter or to just enter into the, let's say, the optimization problem in the local energy systems, these multi-vector energy systems, of course, there has to be a set of dispatchable assets that can be controlled in order to optimize asset objectives. These objectives may be different, maybe to reduce the peak power, to maximize the self-consumption, to minimize the energy cost of the systems, and such objectives are related with the use cases that Sanket explained at the beginning of this workshop. Of course, the scheduling should satisfy operational constraints, not only, of course, balancing energy demand and supply, but also including the technical constraints of the assets or another constraints, for example, related with the comfort of the users, if we are considering in this optimization problem the thermal loads or thermal scenarios. This optimized scheduler is being implemented with a day ahead horizon and an intraday scheduling. Let's start with the optimized scheduler. The optimized scheduler provides these scheduler plans for the controllable assets with these horizons. For example, for the day ahead, example of assets that can be controlled, those equipment related with the HVAC or the electric batteries, electric vehicle chargers. In this project, also for a scenario, it's a port for the scheduling of the movement of the cranes in the port, based on the forecast local energy production and the forecasted energy demand. On the left side of this slide, it can be seen like the inputs for performing this optimization, it is needed to forecast the demand that is not controllable and the generation that is expected to have in the local energy systems. That's the reason that is the second tool, the energy forecaster, to introduce all the sets of the values of the constraints of the assets, the initial values of some assets, for example, for the batteries, if we have an hydrogen tank, the initial status, just to know the initial point to perform this optimization, and also information provided by other sources not related with the assets in the local energy systems, or not necessarily located in the local energy systems, as weather forecasting, information about the prices of the energy or the gas, for example. With all this information, the optimized scheduler performs a search to find the best solution in terms of optimize or minimize a function cost. That, for example, it could be minimize the energy, the cost of the energy that is demanded by the local energy system to the electrical grid, to the gas grid, for example. During the project, working with the 3 pilot sites, the procedure is the same. We first see which is the let's say the structure of the local energy system, the assets that exist in the local energy systems, the assets that can be controllable, the measurements that we need. This is the example I will show in this presentation. The example that is other work has been performed with one of the pilots in the project, in particular the Spanish pilot site, the Hualca Technology Park. In this case, for example, controllable assets they have the the generation of hydrogen, electrical vehicle chargers, and fuel cell electrical vehicle chargers, and some equipment in the EHBC. From the related with the generation, in this pilot, they have PV generation and wind generation, and with these assets, the objective of the optimal scheduler will be to schedule the 4 controllable assets for the day ahead. This is a general slide that shows more or less the structure of the optimal scheduler in terms of information related with the assets, generation and consumption, information about the control variables for the assets that are dispatchable, and the related constraints, the definition of the cost function, and the core of the optimal schedule, the solver. This will be just the picture, just for the Hualca Technology Park. In this case, the definition of the problem in terms of what is being controlled is the electric vehicle chargers. They decide when to charge, and in this case, they have 2 electrical vehicle chargers to decide when to charge, when to provide energy to the cars with these 2 chargers. Decide when to generate hydrogen. Sorry, generate hydrogen is the one. Sorry, the second one, the fuel cell, the fuel gas station. Decide when to refuel the fuel cell electrical vehicles in, and the last one, the control of the chiller in the HVAC system. Just an example how we work this optimal scheduler. We will have this. This is a simulation with data provided by Hualca, that has been added from Hualca, in sense that for one day the forecasting of the demand in the pilot site, the production of forecasting of the solar production, the wind production, that will be information that will be provided by the energy forecaster. External information from from the local energy system, like the price of buying electricity, information related with the weather services, which will be the forecast for the weather, in this case the temperature for the next day, and other additional information that can become from the pilot, from the local energy system, in this case the initial status of the hydrogen tank, and other information that could be considered in this case static, like the price of selling electrical energy to the grid, or the price to sell hydrogen to the gas grid. It would be, this slide just present how could be the outputs of this case from the optimized scheduler. In this case, for the 4 controllable assets, we have the level of production of hydrogen, 100%, 100% during the next day. HVAC, the control of the chiller, one can be started and turn on and turn off this asset. For the both electrical vehicle chargers, when to, based on estimation of the energy required the next day by the cars at Walca, decide when are the best moments to do this charge, and the last one, when to refuel the same way, refuel the cars, the fuel cell electrical vehicles. In this slide, I show would be the results of this optimized scheduler in terms of would be the evolution of all the variables, meaning the variables, the consumptions, for example, of these controllable assets, the electrolyzer, the electric vehicle chargers, and so on. In this case, for the fuel, and this is the result has maybe expected, the consumption of these control assets overlaps the hours of the PV generation. In the right side of this slide, I show this will be let's say the progress of finding the solution. This will be the value of this cost function. For example, this the energy cost from the cost of energy that we demand from outside the local energy system, and the process to find the optimal solution, in meaning the minimization of this cost function. Since for the optimal scheduler can do its work, this forecasting for both the generation and consumption in the local energy systems are needed, this second tool provides this functionality. It provides the functionality to perform this forecast both for demand and production inside the local energy systems. The tool works in 2 levels. The first one will be that allows create the models. In this case, are models that are data-driven models, or is based in historical energy data that has been collected in the local energy systems, related with other information that could be weather information or contextual information, for example, the type of day, working hours, and information like that, in order to obtain these energy forecasting models. And then during the exploitation of the tools, these models will be applied to forecast these energies. Of course, we will need to forecast information like the weather data, or use again contextual data. And in our case, the models are autoregressive, so it also uses past data to perform these calculations in order to estimate the demand and the production for the next day. Just a quick slide. It's not going to more deeply technically, but this, for example, for the consumption forecasting, the type of models that have been developed in the project are based in in techniques like neural networks or supervised machine. It means like tools based on artificial intelligence. Of course, we could, with these tools, we could be able to, this is an example of an output for one particular day, to perform, for example, the forecasting of the electrical consumption, and the same for the generation forecasting. In this case, the models for the PV, the wind, and the thermal generation are based on physical expressions and based on historical data gathered in the system. We perform an adjustment of the parameters of the equations to allow us to calculate, to forecast in this case, for example, the PV generation. Since the energy forecasters are built based on methodologies that are based in historical data that has been gathered in the local energy systems. This third tool, the data processing application, takes into consideration that this historical data may contain, for example, errors, may contain outliers, may contain missing values. Maybe the sample frequency that exists or is collected, the data in the local area systems does not fit with the sample frequency that we have, that has been used developing the optimal scheduler. So this tool performs this work, pre-process the raw data that is measured and gathered in the local area systems, taking into account these four functionalities: to detect outliers, or to detect missing values, then imputate estimated values, both to substitute this missing or these outlier values, resampling, and the fourth one, profiling, that is more, let's say, more no long-term database application, but that would mean it would mean that obtain daily profiles or weekly profiles in order to be used for the energy forecaster or to be used for long-term applications. This is just quick samples of this application. In the left side, the upper figure corresponds to a variable that has outliers, has some missing values. This application to perform this pre-processing in order to eliminate these outliers and complete the record, estimating these values. And on the left side, on the right side, this is a sample of the energy profiling. In this case, the raw data corresponds to several consumptions or different electrical consumptions, you see, during different years, and try to calculate, in this case, in this figure, daily profiles based on this historical data collection. Just as I commented on the beginning of this presentation, in order to visualize, for example, the key performance indicators that have been defined in the project. This slide, there are some of them. For example, the KPIs related with the reduction in the CO2 emissions, or reduction in the peak power, for example, the electric peak power, or the amount of demand covered by the local renewable energy sources in the system, or reduction of the electricity that is demanded to the grid, in order to visualize, for example, all these KPIs and assess during the project how this optimal scheduler is performing, how good are the results of the schedulers that are provided, and of course assess this performance of the tools. ICOM has been developing this data visualization application, and now I will swap to a video. Let me see where he is. This one, and let Isidoros to explain.
Okay, thanks. I will jump in here. And this application,
Isidoros, just a second.
Yeah.
There is some disturbance from your microphone.
Oh, okay. Can you hear me now?
I can hear you, but there's some noise, constant noise.
Sorry. Okay, perhaps we can skip it and I can present it later.
Yeah, the thing is, it's very low noise, which is at the background. Go ahead.
Okay. So this new application in similar manner to the previous one, and it has two different axes, let's say themes. One is for public, which is this page that we have seen here, presenting mostly high-level stuff about the project and its impact. And one is for registered users, where you can have privileged access to fine-grained information about the different pilots. So when you go to the public page, you can see the different assets in the system, the local energy system, in this map view and this tabular form. And there are characteristics of different storage production assets and their location. And then we have different graphs presenting both KPIs as well as some metrics, related to the total consumption, total CO2, the peak power. We have different granularities of visualization, for instance, daily, monthly, or weekly view. We have also other indexes such as the total energy mix or the inflow, outflow per asset, so as to assess the daily, let's say, or weekly or monthly operation of the energy inflows, outflows. And then we have this key performance indication that KPIs that Sergey mentioned, which you can hide, show, or seeing different granularities, as well as battery monitoring metrics. And finally, we have some actual time series data from the pilot, from solar, PV, storage, whatever assets they are there. You can also visualize these assets in this tool, just to connect the dots a bit with regards to daily operation and performance measurements. And that's more or less it from my side. I hope this wasn't too noisy.
Okay, thanks, Isidoros. Let me see, I have this one. Well, just to conclude, some lessons that we have learned from the development of the tools. The first of all, related with the energy forecaster, we due to the fact that maybe sometimes can be a problem in the metering systems. We try to reduce the amount of historical data needed to create the energy forecasting models. So we start always thinking that we need 1 year of historical data in order to get all the variability associated with the seasonality. So we have let's say, learn that we we have to updated these models in order to reduce the amount of historical data needed to create these models. And the second one, related with the optimal scheduler, the importance of course the interaction with pilot owners in order to define what can be done with the assets that are in place in the local energy system, and what is needed in order to implement some scenario, some optimal scheduler scenario in the local energy system. And I think that with this, I conclude my presentation. If there is any question or comment, I will be will give to answer.
Thank you, Sergio. Maybe I can share my screen if you can stop sharing.
Yeah, sure.
Meanwhile, any of the participants, if you have any questions or clarifications for Sergio, please feel free to use the Q&A box. I see that we have some time before we go to the break. So I would like to just show a small video of the ELN project, what we are doing to get a better understanding of the pilots and what we are doing. Just meanwhile, you can use the Q&A or chat, if you have any questions for Sergio. We will take it after the video.
ELAN is an EU-funded project seeking to provide a synergistic solution to the technological, societal, and business challenges that the energy sector faces today. The main concept of the project is the ELN Toolbox, a modular set of methodologies and ICT tools designed to optimally manage multi-vector local energy systems and isolated communities. The modular toolbox can be customized to meet local requirements and expanded to incorporate new tools as new challenges arise. These tools will be tested through 3 demonstrations in Europe and 2 simulated demonstrations in India. The ELN project started in 2019 with the support of the European Union. With a budget of 6 million euros, the project has a duration of 42 months and will bring together a diverse consortium of 14 partners representing 8 countries. The Norwegian pilot is situated at the Port of Borg, an industrial area on a small peninsula in Norway. The area is home to an assortment of industry actors, including recycling plants, district heating, LNG storage and distribution, and food industry. By integrating renewable energy sources, the port can work towards a more reliable and self-sufficient electricity supply. Walke Technology Park, located in the northeast of Spain, is home to the Spanish pilot. Employing around 1,000 workers, the park is an initiative run by the Aragon Regional Government and local city council. The Spanish pilot aims to develop technical solutions with the help of the community. The Romanian pilot is represented by the Valahia University of Târgoviște. The campus's 7,000 students and 400 staff will work in a living lab during the lifetime of the project. The pilot aims to optimize the existing energy structure in order to become a self-sufficient energy island. The first simulated pilot in India is represented by the BYPL electricity supplier, located in Delhi. BYPL serves 1.6 million customers in the Delhi area, with a mix of commercial and residential buildings. The pilot will use the ELN Toolbox to simulate the necessary investments and optimizations needed for the industrial zone. The second simulated pilot in India is represented by the energy community Oroville. Oroville is a small township-based community in southern India. With 3,000 residents, the pilot is powered by a mix of grid and on-site renewable energy and aspires to become fully self-sufficient. The ELN Toolbox will help Oroville to implement its vision for the islanding mode of operation. With increasing penetration of renewable energy resources and high expectations from end users for energy reliability, we need to rethink how we connect and exploit our available energy resources to fully take advantage of the synergies between them. The transition to a low-carbon and climate-resilient economy will require a more decentralized system to be developed, with customers becoming much more active players. With this in mind, ELAN will take a bottom-up approach that moves away from the traditional technical-driven mindset and instead takes time to study and understand the communities' and citizens' needs. With this approach, the ELAN project will be well positioned to develop the innovative and economically viable solutions required for building lasting energy island communities.
Okay, hope you enjoyed the movie. And now it's time to take a 10 minutes break. I will look into if there are any questions in chat or Q&A, and we will answer through the platform. Meanwhile, we'll take a 10 minutes break, and we will be back 4:05 for the integration part. Welcome everyone back. I hope we did not lose anyone. Let me share the screen. All right, so we have finished the break and now we move forward for integration of local energy system infrastructure, where our partners from Schneider and Intracom Telecom will explain how different energy resources will actually integrated from the physical site to the digital toolbox. So the floor is now yours. Isidorus,
Thank you, Sanket.
I will stop sharing just a second. Yeah.
So, okay, so the focus area of this discussion, this slot on tools and solutions within the context of ELN is focusing on the enterprise service bus and integration with the existing or new EMS installed on the field. Just providing the context of what the ESB is. So it's an integration solution that, as we see on one hand, it provides an orchestration of the analytic services of the tools presented by Sergey in the previous slot, enabling them to access data, invoke other services. It enables retrieving data from external data service, such as a weather service, weather forecasting service. It mediates data to other applications, such as a DBA, and essentially it is the main interface with the energy management system. Here we have, in this context, you model this as EMA Cloud, which is the solution that will be presented by Per in this slot later on. So through this interface with the EMS, we get field data from the devices in the different pilots. It happens that it is a cloud solution, so it enables a common interface for all three pilots. And we provide from the ESB, we actually propagate the controls points from the analysis services and the forecasts that were provided by these analysis services. And yeah, just a hint here on some technology we use on the top left. It's not so very important to analyze currently in this telco. So essentially, this is the integration solution of the toolbox interface with the EMS, and it offers a set of features such as message routing, conversion of protocols, transforming data, enabling service interoperation and service orchestration. We also offer, even though it's not very heavily used in the project, message queuing, and of course we provided an interface for monitoring, auditing, and logging the transactions, and of course handle secure communications between the different components of the ELN Toolbox, and especially with the outside world. So what were the challenges, what we aimed to address with our design? First of all, the scalability, ability to support multiple sites, so the 3 sites of the project and perhaps more in the future. Site security, as mentioned previously, since we are dealing with sensitive data, not in the sense though of personal data as we see in other projects, but in the sense that we have granular energy management from field devices in the field, and we also have control set points for the as commands to the dispatch of assets, right? Storage assets or demand response assets and all that stuff. And finally, interoperability, we have different various assets, different flexible assets with different data, providing different data, which we needed to consider in the design. So with regards to scalability, we followed the microservice paradigm, also utilized Kubernetes for deploying this solution, which is multi-tenant and can be hosted on cloud. Regards security, we used, let's say, up-to-date cryptographic protocols, and for even better safeguarding the communication between the client and the server, we use neutral TLS authentication. We have authorized access to all the services using tokens, and the infrastructure we have offers logs and alerts for specific events in the system. And with regards to interoperability, which is a challenge in many projects in the domain and in Horizon, let's say, context. So we have created a canonical data model, let's say a harmonized model of data for information flowing.
Isidoros?
Yes.
Can you go to presentation mode?
I am.
Okay, I see the slides as well.
You see what?
I don't see that you're in the presentation mode.
Let me. No. Can you see it now?
No, can you, in the bottom right, there is an option for start presentation. Maybe you can try that.
This will start the presentation from the top.
Yeah, just trying if with any other option it works. Some yeah, there's some issue with the PowerPoint.
Let me just zoom in, just to avoid all this back and forth and getting dizzy with all this up and downs. Because I have no graphics, so it's fairly simple to present this. I hope it's better now.
Yes, it's better.
Thank you. So we created this data model following the domain standards such as IAC CIM, family of standard, information model. And we extended some of the classes to, for instance, host forecasting, time series, or for modifying some schedule data models. We provide homogenized access to data through REST interfaces. We have some samples documented in the next slide. And essentially for integrating the solutions, we have built adapters for external weather service providers such as MeteoBlue, Tomorrow. We have energy market data integrated for the ENSOE transparency platform for the Spanish and the Norwegian pilot. And we also built this adapter to interact with Cider's solution, the EMA, and transparently, let's say, communicating the canonical data model information flows that we have inside the LAN Toolbox with the structures, the data structures that are communicated through Schneider's interface, a commercial, let's say, product interface. Okay, I'm not sure how well you can see this. Anyway, it's just a class diagram. Essentially, we have utilized the class diagrams of CIM, and we extended with some of the some attributes or some extra classes to host what we wanted as information in the project, for instance, for forecasting. And again, just a screenshot of Swagger tool, the user interface, or the API documentation solution for the REST services, where we have this cyclical user interface enabling both visualization of what are the services, what inputs and outputs provide, and also ability to test the services without even creating a, let's say, local client for this, but just to the user interface. And then I can give the floor to Per. I can stop sharing, and perhaps Per has more luck with sharing the screen.
Per, are you able to connect as a presenter? We had previously technical issues connecting Per as a presenter. Per, you there? Isidoros, maybe can you continue with the presentation as Per is not able to connect?
Okay. Can you share the presentation at least for?
Yes, I can do that. Yeah.
That's the trouble of using a platform for the first time. I hope.
Just let me know where. Okay, this is the slide. where
I also noticed that I cannot share my camera anymore. I don't know why. But anyway. Okay, so Per is from Schneider Electric Norwegian. Let's say the team located in Norway. Perhaps he can resolve this and present himself later on. Schneider Electric has focused on providing the proper infrastructure in the different pilot sites. As mentioned, just to recap, we have the Walca Technology Park, we have the UVTGV campus in Romania, and we have Port of Borg in Norway. Different maturity in terms of infrastructure. We have, existing SCADAs or VMSs, or for instance, in the Port of Borg case, more limited, let's say, infrastructure being deployed because there was a plan to invest also in such items. And if we go to the next slide, the agenda essentially that we followed for working with the pilots and deploying this infrastructure, which was led by Schneider, was scaling of the pilots, existing infrastructure, defining what they call this architecture in the sense of the EMS, right? Analyzing what information, what asset can be integrated and how, and identifying the gaps, investment gaps, and essentially providing an investment plan, which enabled the realization of the different use cases of the project, considering different vectors, heat, electricity, and so if we go to the next slide, there is the architecture of Port of Borg. Now you might see different semantics here. I mean, so I mentioned previously the EMA cloud, which is let's say the cloud solution of EMS provided by Schneider, which has also a user interface, the cloud HMI mentioned to the left. So this is essentially the interface with the LAN Toolbox, the EMA cloud, provides an API for, as mentioned previously, sending control set points, retrieving field data and stuff. And this is, and if we go at the site level, there is a device called Toolbox, which is essentially, okay, I'm quite sure I'm not, I hope I'm not reducing its functionalities, but it's a data logger. So essentially you can get data through it and push it to the EMA cloud, and you can connect, there's a variety of protocols that can be utilized essentially, and as we can see, as we will see in the lessons learned, they selected to use Modbus for the Port of Borg case, connecting to existing VMS and connecting also to PMEs, a smaller EMS, which is, it's called Paramount Expert. It's a solution provided by Schneider as well. And these different assets enable the control of some of the infrastructure, some of the, let's say, flexible assets, such as the thermal heating storage, the battery storage, the battery, and the EV chargers located in the pilot area of Port of Borg. And all these three assets can be controlled automatically. And we also had this crane, these forklifts that, and infrastructure that is utilized for the harbor processes, which cannot be controlled automatically, but essentially we suggested schedules could be applied manually. And then there's a set of assets that were not controlled, but they are monitored in order to profile the less and forecast the daily consumption and essentially optimize the operation of the system. Okay, so perhaps we can move to the next slide, where we have Walca case, the Spanish pilot. In this case, we had an existing EMS, and there was, let's say, it was a quite mature project, and different assets on site, meaning RES assets, PV and wind, and there's also EV charges and hydrogen electrolyzer and hydrogen refueling station, which some of it, okay, most of it, all of it were monitored, but some of it we could manually control. Which other we were able to automatically control, such as the HVAC of some of the buildings of this site. And in this case, the solution differed. Given that it was existing interface, it was easier to integrate with this existing system and a database that was set up, an interface set up for this purpose with the Toolbox, utilizing web services for the integration. And finally, there's if you can move to the next slide. And I hope I'm sufficiently presenting them, since Per was the author of this and leader of this work. We have the Romanian university case where, again, it was pretty mature infrastructure in place, but there were trouble installing, integrating these proprietary protocols that you need to invest a lot of money to use them. So there was a decision to invest in a solution that could enable interfacing the different assets in the pilot site through Modbus IP. Again, there's a set of assets that we could automatically control, quite many batteries, heat storage, lighting, and HVAC elements, and a number of items that we could only monitor. Yeah, and the rest of it is more or less the same. So in all cases, the Toolbox, this data logger enabled interfacing of the pilot site with different with the EMA cloud, and from EMA cloud to the ELN Toolbox. And then we can move to the next slide, I guess. And I'm pretty sure I was faster than Per, having not all the details in mind. But okay, lessons learned. It's easier to work with standard open protocols such as Modbus to collect the data. There are typical integration challenges that you face when dealing with IT, such as security, firewall, different protocols that might use different settings on authentication, for instance, but on the other hand, it's important to build on reliable existing backbones. So the solution of Schneider provided a good level of autonomy on this, and provided us with an API where we could interface these local assets through web services in a level of the LAN Toolbox deployment. And in that sense, we have extended both their existing API, providing their needs for multi-vector energy systems, the needs for reusing and for using external solution providers for the intelligence of operational planning, right? So from ELN Toolbox, we provided the schedules, optimal schedules for dispatch, which was not an existing solution, but an existing interface in their API. That's all from me. I don't know what else I can share with you. There was many challenges also that we faced with the Corona situation, COVID situation, because there is field deployments involved in such occasions, and limited traveling can significantly impact the situation. But okay, this is more project level rather than tool level. So, this is like an exceptional case of our times, I guess. So yeah, now I'm over. You can move on to the next one, I guess.
Thank you, Isidoros, for taking over. Unfortunately, Per couldn't join. Let me stop sharing. Can you hear me?
Yes, we can hear you, and you've stopped sharing.
All right, great. So thank you again, Isidorus, for stepping in. Unfortunately, there was some technical error from for Per to present this. But if you have any questions, you can write to us, and we make sure that Per comes back to you. And Isidorus, you're also on time, so finishing as we planned. I'm just checking if you have any questions on chat or Q&A. I don't find that. Okay, so let's prepare for the co-creation session. The idea is that all the participants actively contribute on how we can work with these tools and how we can improve it further, or how it can be applied to existing cases which are at the moment not considered at the pilot site. So for that, all the partners need to join the moderation platform. I will just add the instruction in the chat, and you will all be able to share your audio and talk after that. Just a second. All right, I have shared the instruction in the chat. What you need to do is, in your video screen on the top right side, you will have a blue button which says that request share audio and video. So if you do that, I will be able to add you on the stage, and then we can have a joint discussion and co-creation session. All right, we have Heidi joining us. If anyone else is having any issues, please text me or text us here. We will fix it. So in the video over upper right side, you will have an option to request to share audio and video. And if you do that, I will be able to give you access to the moderator platform.
And if you're shy to use it, you could also participate later via chat and with the Q&A button there. And then we can also try and interact with you.
Yeah, and just to mention that the importance of participating in the discussion was one of the objectives of the workshop, to get some feedback from the main stakeholders on the use of the tools. So yeah, if you're kind, please don't be shy.
Thank you, Isidoros and Martha, for kindly asking our participants to join. Let's give them one more minute before we can start. Meanwhile, I will just prepare the co-creation board ready. What I can also do is, if the participants don't directly want to join here, they can also directly join the Miro board, which we will use as a co-creation platform. So I will share the link. Give me a second. I see there are already a lot of people over here. That's good. And here is the direct link to Miro board, where you can also join and help us in getting feedback from your end. All right, so the first thing which we wanted to discuss.
Before you start, maybe someone else, maybe the person, maybe to say.
Martha, there is some issue with your headphone. I cannot hear you properly.
Okay, maybe it's me.
Can you put it in the text, because it was not audible. I see there are 12 people already joining the board. So the first thing which we would like to discuss is, so we presented you the 3 types of tools: the long-term investment planning, short-term operation planning tool, and an integration tool in order to create a multi-vector energy system. So these technical solutions, how do they relate to your business and ongoing initiative? So here maybe you can use the sticky pad or the digital sticky notes to write down your reflection on the tool and its connection with your business and ongoing projects. You can simply use your mouse to write in the notes. If you're having any issues, on the left-hand side, you have some additional tools for editing. Feel free to use that.
I think everybody's in a different area on the Miro board. It's to the south. Everybody's on the south side.
Yeah. So everyone needs to come up to the north, where you see the first question, and I guess you see the same thing which I'm sharing right now, everyone, in the video, the question number 1 or the part 1. Is it right? Because I see so many people.
Yeah, I think everybody's in very south of the board,
Yeah.
and actually the board is not what you share. It's interactive through this integration that they have with Miro. We can actually use the board. I can actually guide myself to the board through this.
Okay. So please, everyone, come to the first part where I have typed down hi. So that is where we are now.
Perhaps you could share your screen instead of the Miro board.
I think if I remove that, and everyone will lose the control.
Okay.
But everyone needs to come to the board now, which is numbered 1, and we try to have discussion there. Maybe all the speakers can switch on their video, just so that we can have a good discussion.
Okay. So Heidi is tapping something.
Yes.
Yeah, I'm trying to encourage everyone else to also contribute, because even if I am the coordinator, I'm still probably the least technical person to comment anything. So go on, ask all the silly questions. Now you have the experts on board to comment on them.
Well, again, the question is, it's more than local communities. The tools could be used by providers of services to such communities. And I think we try to map this in question 3 in potential users of the tools. So the impact could be greater if service providers utilize these tools to make something for the communities. So I guess we hope we have a bigger audience than potential users is a bigger audience than the energy communities.
As you presented earlier, this is of course the initial version, but do you think the users can actively apply different kind of subsidies or incentives which are available in their respective countries while using the MVAs or EPA?
I'm sorry, can you repeat that? I was answering a question in the chat.
Okay. No, I was just wondering because different countries have different regulations and different incentives or tariff schemes. How easy is it to implement different incentives and regulatory, let's say, boundaries?
Yeah, actually, those are pretty new to us. So we have started using the MVS on our case study now, and also the EPA. And so we're figuring out more and more. There are certain things that are very easy to integrate. For example, feed-in tariffs and this peak demand pricing, or if you have subsidies, you basically just have to change the costs of your assets, and then it will be already included. I mean, there's certainly some potential for further development for interested people that are not energy system modelers who want to have everything up and ready and very visual. It would be interesting to investigate if subsidies could be displayed easier in the MVS in future projects. But yeah, currently you would integrate them by decreasing the costs of your assets, or adding feed-in tariffs, or adding negative dispatch costs. For example, in India, there is this scheme, at least in Delhi, where you can earn 1 rupee per renewable generated kilowatt hour, and that could be, for example, already included.
Yes, I think it would be really convenient for the users, especially people who are not technical and they just want to simply understand what would be the optimal investment for them. So if they can just select the country and then the tool automatically takes the regulatory boundaries and the incentives available in that country into account.
Yeah.
Yes. Sergio, are you able to access the board? You're muted, Sergio.
Sorry, yes, I have access to the board.
Yeah.
Because
I mean, coming to the short-term operation planning, what are it's a similar thing which applies to the short-term planning. So different markets and how easy is to integrate them with the operation planning tool.
well, in fact, in the project we are focusing in just this local energy systems. I think that it's been easy to implement in somehow in systems of the same size, let's say that. But for a huge integration of, let's say, thinking, for example, for a DCO that may have, let's say, a huge number of generation assets or storage assets. Well, it could be possible also to apply these tools. I mean, we're focusing on in the pilot sites. There was distribution, the CO, the Indian pilot, the Indian pilot is the CO. I think that will be possible to expand these tools for a bigger scenario.
I see.
Particularly local communities, in fact, if they're engaged to invest in these generation assets, storage assets, these operational tools will make possible to perform this, to operate this community. So. As I said before, that's to provide these services to get an economical benefit for them.
Okay, I'm just checking the chat meanwhile while you were talking to see if there are any questions. I see there are a few people who are not part of the project, and it would be really good to get inputs from them. We have Dimitris, Caroline, and Pavlos. At least I see them, which are not part of the project. Can you say hi?
Maybe maybe we can just start and basically start with the first slide and add our input of this, because behind us is a bigger company or bigger institute than just us in Inline.
Yeah.
And maybe we can just add some of our comments, and maybe people are then more keen on adding more content. So maybe we just show them the engagement we want to see.
It's a good idea, Martha. I'm just thinking from outside the project scope. We also have different requests from the customers or stakeholders in order to get some support in planning. So I'm just typing down the question here now.
So yeah, maybe I can answer like the first question, or actually start this interactive part more. So first question: how do these outcomes relate to your business and ongoing initiatives?
Martha, there is a problem with your mic. Can you check the plug for your mic?
The net connection.
Oh, it's a connection.
I don't know.
Perhaps you can skip the camera then.
Is it getting any better?
Yes, much better.
Yes.
Okay, perfect.
Yes.
Okay, so I'm gonna take the first call on answering how do these outcomes relate to our business and ongoing initiatives. And maybe before that, I'm just going to say a few words about RLI first so that we know whom we're talking about. So RLI is a non-profit institute, a research institute, and we do a lot of energy system modeling, dealing with how to implement as much renewables as possible and also integrate it into transport, local energy systems, the energy transition in general, and also off-grid systems, so electrification and local energy systems. So we do a lot of this. We do research projects, but we also do some consulting work. So the MBS and DPI are really interesting for that because we can apply it to the regional, city, and local energy system level, especially for our consulting projects. And actually, there has also already been some interest of these tools. Yeah, so we have used the MBS already for some consulting work for an H2, so hydrogen system in Chile, or 3 locations to be precise. So for us, those are very important. I think that the forecasting tools are also very important or interesting for us, but we are more dealing with planning, and therefore we will have to see how we can integrate those in our system simulations. Yeah, so that's kind of where we are coming from and how we are looking at this. And maybe now one of the other people can say something about their post.
Thank you, Martha. I was just wondering if Heidi is there. Maybe she wants to add something. All right, so
I'm here.
Okay.
Sorry, I was just muted. Let's see if I can get the video to work so that you can actually see me. Yes. Yeah. Well, what did you want to ask, Sanket?
Just how these tools, how do you think it would relate to our company or organization?
Well, of course, for us, it's extremely important to work on solutions that support the sustainable development and support the sort of reduction on emissions. So all these tools are basically also aiming at using the resources and the assets more efficiently. So from that point of view, these are extremely important for the company strategy and the work Sin is doing. And then we see that these kind of tools and development can really empower the communities and the local groups, and I think that's quite interesting from the business models point of view. So this could lead really interesting new business models and create new business opportunities and new jobs. So extremely important.
Yes, in addition to that, I mean, we have been working a lot with the local companies out here in different domains, and this is very relevant topic for them because it helps them improving their efficiency in the business, as well as they can also use it as a marketing tool that the services or products they are providing are made in an environmentally conscious way through green energy. And from that point of view, it is very relevant on how first they can optimal plan investments in different resources, and also do a more efficient forecasting on when to buy which type of energy or use what type of vector and energy. So both the things, I think, relate very well.
Absolutely, I fully agree. I will unfortunately need to leave in about 20 minutes, but until that, I will be happy to chat with you guys.
I think maybe we should move to the next slide, since we don't know who else are. So maybe it's better to go to the next one and discuss about additional features and improvement going forward with respect to these tools. Of course, the participants can do the same thing again, add what they think is relevant to them, which they want, but they did not see it as the tool exists now. I see some people trying to think and add possible new features. Here we have a simplified and more integrated consideration of subsidies. As is, people are interested in providing inputs for investment planning. Detailed energy asset types. I'm just trying to understand what it means. Is it something? What are the characteristics of an energy asset that has to be more in detail defined, or the tools should allow the more detailed description of the tool? Sorry, not the tool, but the energy asset.
Yeah, that's for me. I'm not sure if you hear me well.
Yeah, that's fine.
So, yeah, just as I said, Umov Solve has more detailed energy assets types, and there is also limited ability of them to, for example, include generators with an efficiency based on the load factor, and such assets would be interesting. They are much harder to implement in the MBS, but it would be interesting to add them. Yeah, and I just think this should be something on the list to keep in mind that it is possible. Yeah.
Okay. I'm just wondering, a topic for Isidoros, that would be, when it comes to integration, because you have been working closely with Schneider, how, let's say, complex or how easy it is to integrate the existing assets and their related energy management system with the ELN tool on the back end, in terms of both the resource, in terms of expertise, as well as time needed.
Well, integration is like a barrel without an end. So yeah, it's very usually it involves a lot of effort in working with existing solutions, and there are legacy protocols or closed protocols. And fortunately, in ELN, we had the ability to move aside all these barriers and make this work. And fortunately, Schneider has provided us with this API to expose all the services that we envision in operational planning. So we could both get data, which, perhaps is less challenging, but also provide the controls and the schedules without dealing too much with the integration of the different, let's say, controllers of the assets or VMSs. Which, again, if you go at different, pilot areas, effort could differ depending on the infrastructure. But there's an interesting question by, I don't know by whom. This relates, it's about integration, but it's integration with markets, local energy markets, which could be something that, as a possible future, let's say, consideration. Personally, I've added a similar comment on just left of it. Under operational optimization, which is interfacing with flexibility markets. Local markets, flexibility markets, there's none of it, so there could be many markets in the future. The sense is that if you formulate an energy community and essentially you can keep, you have an area where you manage, and how can you expose the services to the main grid or request services from others, and this is something that would be interesting to see. So apart from keeping the balance within your area, within your local energy system, how you provide services, which is something that we modeled as a use case, providing flexibility service, but we were not able to test somehow, being that we do not have a point of integration, an existing market, or somebody able to simulate such a market in the project. So yes, I would say this was an interesting feature for the future for operational optimization.
Yes, I agree with Isidoros. In fact, we talk about the targets that can be considered with this optimization. It appears as one possible target to reduce the peak power, the power that is demanded to the electrical grid, for example. In the project, or in the tool now, this peak power has the clear meaning of if we reduce the peak power, there are some part of the electricity bill that depends of the peak power consumed from the grid. But also this can be seen from the point of view of the DCO, that if the peak power reduces, and somehow it can help the DCO to reduce, let's say, the load in their distribution network. So in this case, the user, or these schedulings of the loads inside the local energy systems, in fact, helps to the DCO, and this is a business that can be let's say, a framework that can be used to take profit from the users, not directly from buying the energy, but helping the DCO in this case to run more efficiently or less stress their installations.
Yes, and additionally, I'm just thinking, because when we talk about markets and, for example, this flexibility services, we mostly talk about electricity, but there's something, I mean, it would be interesting to see what happens with, for example, the heat or the gas sector, which is very rarely discussed, and how services can be taken or provided to those markets.
Yeah, and that, like, I think, Sergey, we've been discussing it a few times. Like, what happens when the same actor wants to participate in with their assets in multiple markets, and how that could be solved. So
Yeah.
there is a lot of interesting future research questions to be solved, definitely, around this.
And I see there was a new question for Martha, or in investment planning, simplified and more integrated way of doing sensitivity analysis.
Yeah, that's also a feature requested by our stakeholders. And we have a way to do it with the MVS locally if you have some programming skills. But it could be eased both in the MVS, and it could be potentially integrated in the EPA. And I think that would make it quite, interesting for the end users of the products.
Yeah. All right. I think we are out of inputs here from the participants. So I propose we move to the next question, and that is regarding potential users of the tool, which to me is very interesting, because then it opens opportunities where the tool can be exploited. So we have already identified some of the potential users in our stakeholder analysis, and we mentioned some of them, but it would be interesting to know from outsiders' point of view where it can be applied as well. Maybe we have not considered some of the users. So, Isidoros, I just, meanwhile, while people are thinking and providing their inputs, I would like to know from ICOM point of view, because ICOM is a turnkey solution provider, and how do they see at least the investment planning and the operation tool considering a complete solution?
Well, what we try to do with investment planning is create something that can increase its impact in terms of audience. So hopefully we have achieved a first step on this, and we can see what happens in the future on providing. We already have a list of features that we could investigate in the future, but we not want to take hesitant steps on what would be of interest essentially to the end users until we have some solid feedback on this, and perhaps some exploitation plan, projects, collaborations, and all this. And in regards to operational planning, we already have, through other project, a link with the solutions that's being developed with from UDG. And I think they are maturing as we go along and considering different contexts. For instance, now it's in this project is about local energy system, and another project is about distribution grid optimization. So it's I think there's a good level of progress on how we shift from a prototype to something that can mature as a at a higher TRL, let's say, level.
Yeah. Okay.
And the thing is that we need to validate all this solutions in pilot environments and essentially promote this as systems that can be, or subsystems that can be integrated in systems that already have a place in the domains, the business domain, where stakeholders already use some systems, and we need to see how to plug these solutions there.
Yeah, we definitely need some validation from the piloting, which brings confidence, definitely. And in your experience, I mean, I know you are actively providing solutions to DSOs, but are there any other, customers you have which might make use of these tools?
But personally, we are engaged in activities that cover DSOs. We have other projects with aggregators, or let's say retailers, and my view is that this set of tools is focusing on a specific context. I mean, they cannot be used as is in another context. They need modification, but this can come through collaborations, through projects, through new use cases that you can expand your solutions. So as course functions, for instance, forecasting or operation optimization are functions that are needed by different stakeholders, both for the local energy system or the microgrid, so to say, operator, but also for the, let's say, distribution system operator. But there are different items to consider in this optimization, formulation of optimization problem, or for the forecasting of different assets. So you need you cannot shift from one context to the other without having proper effort and the requirements by the domain stakeholders.
And Sergio, just on the similar lines, do you get some interest or questions from the industry on what or challenges from the industries where these the operation planning tool can be used to solve their problems?
Well, as Isidro said, this is a potential interest in this. We have talked just a few minutes ago related with these flexibility services. This is, for example, something that in Spain is not still open. This kind of services. So in the future will be open, and there will be other actors like aggregators that could be interested in such tools. For past projects, for example, when I presented the tools, for example, the energy forecaster, I presented this tool as a tool that is needed in the lab project because of the optimal scheduler. It is true, but the energy forecaster may have another interest, for example, for facility managers or building managers, and in the sense that this forecasting and the energy that the building or the local energy system is going to consume may help to estimate the cost of the energy, the budgets related with energy, or detect the deviations from what is expected, and in fact use this tool as a let's say a monitoring tool, and would be helpful to assess that the expected let's say how the building works, how the localized asset locally works. It works as is expected. There is no deviation because there is some bad use of the energy or bad use of control of the assets. In this sense, for example, the energy forecaster has these others uses that are not directly related with the context of the LAN project.
All right. And I just saw that Harry mentioned an additional user, that is neighborhoods apartment building association here. I think, yeah, that is very relevant. I live in a neighborhood.
I thought sort of that it's different from energy communities because I consider them as being more mature user, but then, as we know, energy prices are going up in ridiculous speed. There starts to be a lot of, let's say, people who are not very happy with the current solution, and they might want to get more independent. So that's why I thought that maybe these kind of like building associations, or I'm not sure what they're called in English, but basically a lot of people living in the same neighborhood and having some kind of agreement with that.
Yeah, I think, I mean, every
Yeah, I
country has
agree.
its own term definition. Here we have, in Norway, I have seen there is an association for buildings. And then in India also we have that is called Residential Welfare Association, which is group of buildings which come together and then they take, for example, the maintenance and cleaning. And now energy is also a big component of such associations. And I think it was not in the ELN context, but in previous Horizon Project Invade, if you remember, Heidi, we had this neighborhood association from Oslo.
Yeah,
They had funding support from the government to have PV and to install in batteries, and they had a lot of EVs which were owned by the residents. And then they wanted to find out what would be the optimal investment in PV and the charging station.
absolutely.
And I see that this is growing even more. And sorry, Martha, I cut you off, so go ahead.
Yeah, there's also something like this in Germany, and it's called actually like Citizens Power Movement, something like that.
Okay.
So I also agree that definitely our tools could be interesting for that. But I think there needs to be someone in between, maybe an NGO which is able to do the kind of give the technical inputs or cost inputs or insights or something so that they can enable those citizens to get active. So I see this rather as workshops together with NGOs, and I think those would be really interesting.
Absolutely.
Yeah, I'm not sure in Germany, but at least in Norway here, the board or the residential welfare has a board which is registered as a non-profit. And then they make all the energy or any decision for investment in the neighborhood. So at least in the Norwegian context, we can target those residential boards. Yes,
Definitely.
Heidi, you were saying something.
I need to leave now, but thanks for great discussions. Very good presentations. Every time I listen to you guys, I learn more about our joint project. So it was definitely great, and I hope you will have a nice end of the workshop.
Thank you.
Thank you, Heidi.
Then maybe with that, we can go to the last slide and dream a bit more about what we can do. So you said in Norway you have those citizen boards.
No, yeah, residential board, or it's called Samia. I can write it down. I don't know how to best pronounce it, but yeah, let's see. Does it sound something?
Yeah, it would be really interesting to have different people from different different work packages and see if there's already something like a 2-part workshop that we could compile, which addresses NGOs and citizens, like something smaller and not as technical.
Yeah.
But to be honest, I'm also not quite sure what the citizen community engagement workshop exactly did. I haven't participated in their workshops. Maybe that is exactly what they mean, but I'm not sure.
Work package too? Okay.
Because I mean something really condensed. I'm not sure that. I think theirs is quite a big package. So.
Yeah. Of course, I mean, since we don't have much inputs here at the moment from external stakeholders, maybe we can quickly discuss on what we can do beyond actually the ELN project. This can be a good time to discuss. Either it can be a new project or...
Yeah, I mean, what I just meant is actually exploitation. Like providing like a packet with which we can then address those NGOs for citizen power. Another opportunity to develop further would be for me to look more into the socio and socioeconomic aspects of energy communities and energy system planning. As I mentioned like earlier, with something like a multi-criteria assessment, so that it's not just the economic optimum, but also considers how the citizens can engage and the local benefits that they can reap from implementing sector-coupled energy systems. That's it could be a big new project.
Yes. Have you identified any call for such kind of project?
Not really. So, I mean, the project we developed last year, Integer, I think, that was pretty much going in that direction. So we already tried, but I think we should check if we want to try again with another tender, but I haven't identified one yet.
Okay. I'm not sure if Pilar is active here, maybe because I know we have been discussing what on the similar lines in parallel conversation, not here. Maybe she has some interesting insights for that. Or otherwise, there are few open calls which we are also targeting, which actually focus more on how using the tools which are already there, we can develop specific services and sell the services to the energy.
Yeah, I think Sanket is frozen now. But I agree. There is still a step forward to go to compile our results into services that we can sell more easily.
Yes, so it's more for focus on packaging the services and developing it. I just saw that everyone was just frozen for a few seconds. So I'm not sure what's happening with the platform, but maybe let's do one thing. We can quickly wrap this up and finish with the workshop here, because we already identified a few avenues: horizon projects, commercial projects, and then we discussed about the citizen residential welfare boards. What had we mentioned, we can add it here, identifying solutions. Yeah. Of course, this has to be packaged in a proper service, but this is something which can also lead to future collaboration. Well, I can go on talking, but are there any closing words from Sergio and Isidoros?
Well, in our case, obviously, the collaboration opportunities, the door that is we always knocking is the thinking in new proposals, or thinking of participating in new proposals to expand the tools we are developing.
I cannot understand anything. I cannot understand anything.
Sorry.
I'm not sure why.
Sorry.
I don't know. The audio on this platform is not very good.
Muted. Can you hear me?
Yeah.
Yes, I can hear you well, Sergio. No issues from my side. I think there's some problem.
Okay, so I saying this
with platform
this new
Germany.
These new proposals, expand the tools that we are developing, the social aspects of the let's say the social engagement of user is also a topic that we are we're having in mind, just not just developing the tools from a technical point of view, but also as to exploit it to engage the users to adopt these technologies, these tools, and also the commercial part. Well, we are thinking also we have to expand these tools in order to enter somehow for in the market. As a university, there are some limitations to do that. It can be done, but this is the door that I think that we need to, well, we're interested to open, but of course it is as it is in this last slide, cultural opportunities, until these tools are not let's say tested in the pilots and the project, or tested in other contexts. So this door is still let's say somehow closed.
All right, thank you, Sergio. I think it's time to wrap up now. I thank you everyone for participating and for sharing with the external stakeholders what we are developing in the project. When it comes to the technical tools, I hope the participants got interested and they will come back somehow to us asking more information. And I will finish this workshop again, thanking you all. And we talk later in the project. Thank you all.
Yes.
Thank you, Sanket. Thank you, everybody.
Thank you all.
Bye-bye.
Bye.
Bye.